Recording has started.
Hi, Federica.
Hi. Hi, how are you?
All right, how are you?
I'm good. We're gonna wait obviously a few more minutes before we start.
Hello? Can you hear me?
Yes.
Hi,
Great.
Rachel. Hi.
Hi, Sid. How you doing?
Hi, people are joining. We should wait. Jacques is already here. Excellent. We should wait a couple more minutes. Also, we don't have picture yet. I don't think we do, so we're definitely gonna wait a couple more minutes. Hi, Rachel. Rachel agreed to take notes for us. Thank you very much. I'll probably ask rotating chairs to do the honors of taking notes because I am unable to do that coherently. Um, so thank you very much for helping out, Rachel, this time.
Sure.
Jelko, are you online? Can you hear me?
I can. And Victor
I
just
just
joined.
wanted to. Excellent, fantastic. Jelko, I just wanted to make sure you mentioned the recording is going to start automatically. I don't see any signs of it,
Yeah, I
so
can see
I'm just
recording. It is
excellent because
being
I think you're
recorded.
the host.
When I logged in, a voice said recording had started.
Excellent.
Me
And there's
too.
a red dot in the upper right.
Correct. That's
I
the
don't.
signal that
Um,
is recording.
oh, on the upper right of my own window. Okay, awesome. Excellent. Thank you very much. Thanks everybody for joining. I think we have critical mass. So um, we had a small hiatus in these calls, but we're going to try to make them as regular as possible going forward at a monthly cadence. The next one is going to be in January, just no need to add one in December since it's already the end of November. But we have a small schedule that Jelko and I have put together, and I'll submit it to you all in the next few days. So Victor today agreed. Thank you, Victor. Victor is the LSST project manager, and he agreed to tell us about the plan for LSST in 2018. Which is a topic that was originally proposed by Megan. Thank you, Megan, for proposing the topic. So unless there are some really, really critical questions, I recommend the questions get submitted through the chat. I will try and monitor the chat, and then if I see any questions that are compelling during the talk, maybe Victor, I will stop you if I see a point where the talk can be stopped and ask them. Otherwise, we'll ask them at the end. And if there are no objections, I think we can proceed.
Recording is on recording. Great. Can you hear me okay?
I can hear you.
So I'm going to go ahead and share a screen here so I can present.
Also, let me add, if you didn't check your email, the slides were shared on email as well as on Slack on the side chairs panel.
And there may be one or two slight differences, but I think
You're really, really faint for some reason.
I have the same problem.
Yeah, a couple of people mentioned that on the chat as well. You're just not very loud, Victor.
you don't usually have that problem. But I'm going to do something a little bit different. I'm going to start by starting the slide presentation, and then if you give me 30 seconds, I will get a different microphone.
Okay, perfect. Also, Phil is asking if the slides are, if we can share the slides publicly, or if we can share them, I guess, at least with the rest of the collaboration.
I believe that these are suitable for sharing, yes.
Excellent, thank you.
Give me 1 minute.
I'm going to take this minute then to mention, I want to make this, I want to open a channel on community to discuss these talks further and to share the content of the talks, the menu and the slides more broadly with the science collaborations, with the entire science collaborations, and hopefully to have intra-collaboration conversations about these meetings. So I'll open a channel on community, we'll upload the slides as well as the menu of the meeting there. It will be also linked through the slides and the video that are posted on the scientists LSST page. You'll get a link on that on Slack. Link to that on Slack.
Okay, how about this?
That's so much better. Thank you.
Perfect. Okay, so thank you again. And also, feel free to break in at any moment. I'm fine with I'm making this a little bit of a conversation if we get to that point. So feel free to break in at any moment. If I can tell that you're trying to do it, I'll try to acknowledge. So what I put together here was a little bit of a status, as well as some interjection on what the 2018 looks like. So I felt like 2018 might need some context so you understood a little bit about where we are today. And I might go through this fairly rapidly. It's hard for me to appreciate exactly how much of this might have already been discussed in various forums and how much of this you might already know about. So I thought if I just go quickly through it, then I'm happy to retrace and talk about any aspect that catches your attention. So just to start with, as a project, from the project standpoint, just to get the numbers over with, I promise this is the only number slide that I show from a management standpoint. Just a reminder that we do have two phases of the project. We do have an NSF side and a DOE side, and those projects have a total project cost of $473 for NSF and $168 for the DOE. And if I just skip down to the fourth line, it gives you a sense of how far along the whole project is in terms of percent complete. And so on the NSF side, we're almost 50% done by the end of September, or at the end of September. And on the DOE side, the LSST camera fabrication is at 72% complete. On both sides, we have remaining contingency, and I would describe that contingency as it looks reasonable for this stage, but it's really quite tight because we can now start to predict all of the things that are going to be calls on contingencies that are still risks in the project. And so I don't want to make it sound too great that we have almost 30% contingency because a lot of that is starting to be spoken for in some of the risk areas. So, but overall, I would just say that the project is in good shape. And by the numbers is progressing quite well. If we look at now go into some of the details, I have some very image-based slides here for the construction and fabrication parts of the project. And this is a really good example, the iconic how well are we doing on the summit. And on the left, you can see our early rendering of what the summit facility would look like. On the right is a picture taken today. So clearly the building on the summit is moving along quite well. For 2018, you can expect that the fixed bricks and mortar part of the building, or otherwise known as the prime contractor, will be completing their effort in January. And then the principal activity will be in erecting the dome, which is a different contractor. And that dome will be the primary activity for the first half of the year. And hopefully come about August timeframe, that will be looking quite a lot like what you see on the left. And so here's a slide just showing some of the dome activities. Even though the prime contractor is not yet complete, we have started an overlap activity, and the dome erection has started. It starts with the interface to the form, the concrete of the lower enclosure. You can see on the far left, rail assembly, and again a picture taken today in the bottom right, which is the box beam and bogie assembly, the rail and wheel assembly for the dome. So you can start to see that assembly and erection process is very much in full swing. Another key activity, of course, is the telescope mount itself. And on this slide, number 5, you can also see again the rendering on the left of the design, and a picture on the right taken a couple of weeks ago of the trial assembly in the factory in Spain, of the status of that activity. The next slide, 6, you can see some more of the components, including the top end that was missing in the previous picture. And on the right, although the image is not very clear, that is the cable wrap assembly for the camera itself that allows the camera to rotate on the top end. and that was quite an ambitious activity. For those of you that are familiar with the telescopes and where they often fail, it's often in the cable wraps, and they end up being very difficult. And so we put a lot of attention in this particular fabrication effort, which is why it warrants a picture there on the right. That overall factory testing has been going quite well, and the assembly is coming together nicely, even to the point of having tested the hydrostatic bearing system and starting to get to what you see in slide 7, which on the video probably is a little bit fragmented. It's much smoother in real life, but just to show you a little bit of what the telescope now looks like. And the video is nice because it actually shows people in the scale. So you start to get a sense of not just what the progress looks like, but what the scale of that factory and what that factory assembly was looking like. So again, that was also just this week. In other areas of progress, the coating plant is being developed by a company, Von Ardeen, in Germany. They are also moving quite far along, having already built the chamber and done the vacuum testing. And the chamber you can see in the image on the left. On the right, they're also responsible for the whole cleaning station and the coating stripping and coating prep area. And so that's some of the boom crane, some of the steel hardware that you see required to do those functions right before we can actually coat a mirror. And so that's all working well, and should also see completion in the factory in 2018 with shipping planned in about the June time period. Another real critical activity, I think hopefully you've all seen pictures of the actual primary mirror from the past before we actually stored it. That's been in storage for several years now, waiting for us to complete the activity noted here, which is the entire assembly for supporting that glass, which takes not just a very large steel cell, which is the turquoise item that the gentleman on the left is standing on and you can see on the right, but also an incredible amount of electromechanics, hardware, pneumatics, and other devices to properly support that mirror. And on the image on the right, that rusty steel item is the dummy mirror for the primary tertiary mirror. We actually put a significant amount of engineering effort into that particular item so that it's not just a surrogate mass, but it's also representative of the volume. So we can do further testing of it without having to put the glass in jeopardy. And it's also structurally very similar to the glass. And so we can also do further testing of all of those mechanics and hardware that has to properly support the glass before we put the glass in jeopardy. And so this has also been one of the activities that we have performed what I'll call in-house, because it's mostly LSST personnel working on that particular. Another area in what we consider to be the telescope and sight scope is in the auxiliary telescope. And you might recall that we do have a 1.2 meter class telescope that we will deploy on the neighboring summit to primarily look at water vapor and look at the transmissive functions of the atmosphere while the main telescope is operating. And what you can see on the left is that telescope previously was a Calypso telescope on Kitt Peak that was donated to us. We've refurbished it. That refurbishment is nearly complete, and we will be sending it to the summit to go in the dome that's in the foreground of the image on the right. And that should be sent down also in 2018 in the mid to the later part of the year, going into sort of a commissioning phase. So all of this, if we now focus on, 2018, almost every picture I showed has hardware going to the summit in the next fiscal year or the next calendar year. And so the next two slides is really just to really emphasize, mostly for our logistics team, just what is coming, what is coming, and what we're preparing for. So the slide on 11 is just a screenshot of one of our spreadsheets that shows there's nearly $100 million replacement cost of hardware that is being shipped in 2018 to the summit. And it's not just sort of about 30 items that don't fit in containers, but it's also, if you look on the next slide, it's something like 70 different containers of material that are all going to be shipped to the summit. And so in total, we're making plans for a lot of cargo to be shipped and something like an equivalent of 100 truckloads of items to get to the summit. So anytime you see a picture of the summit, you see how tight the top area is, the top plateau. These kinds of slides and these kinds of numbers of items sort of brings to reality just the effort that's involved for the team on the summit. And all of that is planned for the latter part of 2018. In addition to the main construction activities that we often talk about in the summit, we're also building a 10-person or 10-room addition to the hotel on Cerro Pachon, and that activity is also starting this year. We've just finished the architectural work. The image on the right, the first two wings towards the lower right are existing, and it's the top left one that is LSST's new contribution with 10 rooms. In addition, we have another construction site which is in the base in La Serena itself, and that you can see on slide number 14. We have been doing a joint project with our neighbors and with Aura to do quite a substantial refurbishment of existing facilities that also ostensibly makes room for the fairly large addition that LSST is required to put in place to support the ops team with basic office space, but also for the data acquisition for the base data system. And so the image right there, anything in sort of yellow tan is existing buildings, and what's in the greenish color is the new LSST additions. And in the top right green, smaller portion of the T, that is the data facility. So if I change and turn our focus a little bit to some of the other fabrication activities, in particular the camera area, one of the key aspects and one of the key risks for the camera fabrication all along has been in sensor delivery. And as of this month, we can report that 56% of all the sensors, or 118 out of the 208 that we need, have been delivered for the science grade to go into the focal plane. There's another 20 that are not 100% to spec, and so we have them sort of a science grade reserve, because there's some feature on there that we don't like, that doesn't make them fully qualified, but we would certainly use them if pressed. And so that's another 20. And so we're, if all else failed, we'd have 66% of the sensors as of today. And so that's moving quite well at this point. And most importantly is that both of the fabrication efforts and the assemblies at both of the two vendors, E2V and ITL, they're on a good trajectory. Their deliveries over the last several months have been consistent with the trajectory that we need to see keep happening. Past performance is often not often the perfect indicator of the future, but at this point in time, things are looking pretty good in that particular risk area. Of course, those sensors need to be turned into a focal plane, and you may recall that our focal plane is made up of 189 of these 4K by 4K devices, and we build up that focal plane in rafts, and each raft is 9 sensors. And so what you see here is we start talking about raft tower modules. 8 of them have already been completed, including 2 engineering test rafts. And what you can see here is the pictures. In the pictures is one of them on the left, and several of them loaded up in the testing area on the right hand image. And to sort of further emphasize what you're seeing there, each raft, in addition to the 9 sensors, includes all of the electronics and utilities to drive those sensors and read out those sensors within the same footprint. And so you see the electronics is what's sticking up in that image, with the sensors at the bottom of each of those assemblies facing down. And of course, the way that the activity has been organized, these rafts are being built up at Brookhaven and then being sent over to SLAC for integration into the overall camera. Another critical area for the camera is in the lenses. You'll recall that the camera has 3 refractive optics at the front, 2 L1, L2, and then L3 is the window to the doer. And those activities are moving along. If you've watched or heard along the way, we've had our share of issues with some of the fabrication efforts, but in every case right now, they are moving along and on our revised schedule. But fabrication is looking good, and here you can see some of those images in the various pictures here. I guess the other point to make is one of the complications that the camera team had to work through is that the broadband coding is being provided by separate vendors from those that are providing the optical fabrication, and so that puts an added activity on the actual project team itself. But it's happy to report that those lenses are on their way to Europe for getting that broadband reflective coating installed or applied. And so those lenses are really getting to the final stages of fabrication and delivery. There's a significant effort going on with the camera filter, the exchange mechanism in France. And here you can see some of the images of the auto filter changer and the rotator. We carry 5 filters in the camera at any one time. And of course, those 5 filters need to be stored and be able to be inserted at any time. And so that mechanism, including the carousel and the insertion mechanism, is a significant electromechanical device that the French have been working on for several years. And as you can see from these pictures, the progress has been excellent, with delivery expected late in about a year or so. Other areas of critical fabrication for the camera has been sort of the cryostat, which you can see on the far left. The grid itself, it's a CSIC grid, which is the back plane or the support structure for all of the 21 rafts that are and the 4 corner rafts. Those are all mounted to that grid. And so that's been a particularly critical fabrication item. You might have heard that last year we did have a tool break one small part of it that has been repaired, and the repaired item has been fully tested and is fully meets all requirements and has been delivered and is sitting at SLAC waiting for final integration. And lastly, on the far right, another critical item has been the cryo plate. This has also been quite a challenging fabrication effort. This is what provides the main cooling heat sink for all of the rafts and becomes a very critical item to the overall focal plane operation. And so that's been a high risk item for the camera team for some time now, and everybody's looking forward to that delivery late this month and getting it to SLAC early in the year. So there's sort of a really quick walkthrough of where the main fabrication items are. There's incredible amounts of other activities that are going on, of course, in that sort of area of the project, which is what I've sort of labeled as the construction and fabrication areas of the telescope and camera. And as we really focus on those parts, we also have to be really cognizant of just the whole safety aspects. And so we have really worked hard as a project on both the NSF and the DOE side to really make safety an important part of the culture. And so we've been, that team, which includes people here at the project office and at SLAC, have been working hard and working together to make sure that we present safety as a single project effort and really focus on it, not just with our own people, but with our vendors. And just to emphasize just the challenges that team faces, it's not just the fabrication of our own things, it's working with vendors, it's making sure that culture is embedded right at the get-go with looking at hazard analyses and so forth. But also, we're well distributed at this point. I mentioned the summit activity, the base activity, the hotel on the summit. So there's 3 major construction areas, as well as some fairly significant fabrication items that are going on, both here in Tucson and at SLAC and Brookhaven. So there's a lot of activity going on there. I just want to emphasize that this is something that we take quite seriously and work hard to keep all work moving and working along quite well. So now if I switch over to the other significant element of the project.
Sorry, Victor, then there is a question. Yeah, there's a question by Phil Marshall, which may be worth asking at this point before you switch. What would the impact on camera performance or image quality be if the L1 fracture was not repaired?
I believe, and I think that if Steve Ritz is on, he might actually have authored some of the analysis to look into that. And at this point in time, every single feature, my general response is every feature that we have, that we understand exists, has been evaluated, and we have reports that we can share on what the overall scientific and technical performance impact would be. And I know that that's not as satisfying as here's the quantitative evaluation, but I'd have to look up the actual numbers.
So, Victor, this is Chuck. I don't know if Steve Ritz is on, but the short answer is nothing noticeable. It's at the negligible level as far as impact on science performance.
Equally non-quantitative, but
well,
yeah,
it's unmeasurable as far as impact on throughput and impact on PSF.
Yeah, you should emphasize this is Steve Kahn. The reason for repair is actually not to improve performance. The reason for repair is to polish out the figure so it's not a source of further fracture and a stress concentration. So it's really unrelated. It's completely unrelated to performance. It's just the safety margin for the lens.
Thank you. Phil sent a smiley face on the chat. So I think we're happy.
Okay. Yeah, I think Steve's point is really good. It's really important that we understand when there is an issue, particularly with glass, we look at it from 2 standpoints. One is overall system performance, but also the technical performance and the technical safety of the glass itself. And passivating the glass so that there's no further fracture is an extremely important part of any of those repairs. Okay, so I was about to step into the data management area of activity, and I assume that I don't have to go into the details of our data products. I think that there's lots of good documentation that exists. When I did want to I just want to put this slide out there, and the main message I wanted to give you was that we have gotten feedback from many of you on this call to discuss the ambiguity of level 1, level 2, and level 3, and what you should be seeing in the documentation that is coming out very soon, or in fact has come out, is this change of nomenclature where the stream of time domain events that comes out on a nightly level we will call no longer level 1, but we'll call the nightly data product, and then there's the the database itself of all of the of the catalog of objects, and that will be no longer referred to as level 2, but will be referred to as the data release data product. And lastly, we've always discussed the ability for people to federate into the software that we provide or into the infrastructure that we provide. And so that data product and that capability will be referred to as user-generated data products. And so that this is actually quite new and fresh and is in direct response to a lot of the feedback that we've gotten from, like I said, many of you on this call.
You mentioned that the documentation has been released about this.
So I believe that those of you that provided feedback to Mario's slide set on this topic have probably seen the discussion and will certainly be seeing the reports that come out on declaring the terminology that I just used. But if you aren't on that, you'll see it in the update to the status paper that Željko is updating right now. So maybe Beth or Željko want to say more about how people will hear about this officially. However, those are the terminology that we were leaning towards.
Yeah, that's great. So I think that we've almost closed the loop on minor edits to the slide deck that was shared with the science chairs a month or two ago by me. And then once those edits are finalized and that gets a LSST document number, I'll recirculate it to the science chairs. And of course, you'd be free to share it with your science collaborations at that time, if not already, and that will have the terminology. And yes, to Victor's good point about Željko's led update to the overview paper, deploying this new terminology. And as the members of the data management subsystem science team are interacting with the individual science collaborations, they will also start to demonstrate and to use this terminology.
Thank you.
Okay, so from a status standpoint on the data management side, this slide you can read in further detail, but I think the heading is really what's important. And over the last year and a half, I think the data management science group has really focused on what are the user needs and thinking about what the capability of the data management system needs to be to support the users. And what you can see here is sort of classes of in this incremental, very coarse class of user, where the first two bullets are sort of maybe referred to as the introduction. Those that want to just get a small data set, bring them home, do their own analysis either locally or with maybe their own well understood and data tools. And so there's sort of that level of engagement that we have to support and recognize. And then, of course, you get into the next level, which would be the third bullet. There's going to be a certain, I would actually assume is going to be the bulk of the users, but that's just my perspective. The people that are going to want to really engage much more closely with the data are going to bring maybe their analysis to the data itself and really address their science cases where some people might need more computing, but not more space, but some might need more space and less computing, but it really is done best really local on LSST hardware. And so that capability has to be understood and supported. And then there's going to be the very demanding user base, those people that are going to want to either take LSST, not necessarily LSST resources for computing, but bring the data or marry the other capabilities, higher level computing capability with our data set. And so we also have to be able to support that kind of analysis. And then finally, there's the user groups that will want to set up their own data centers, and if they've got data rights, take the data themselves and bring them into local data access centers of their own. So this is a fairly coarse way to look at it, but really has been a big help to the data management team to really focus on what the delivery should be and to really make sure that what gets delivered is usable from a scientific standpoint. And the way that what that turned into is, and again, here I assume that many of you have already heard much of this and seen many of the presentations and some of the material, particularly over the last year that Mario would have presented. You get to this this idea of a science platform, and that platform has, as you can see in the sort of the middle or the top blue line, sort of this 3 levels of engagement, where we discuss the portal as those people that are going to just do small data release exports or imports, work with it in that sense. Then there's sort of the middle group where you really want to engage more fully, go to our data set, and that's where you're going to work off of these Jupyter Lab notebooks and really support your science mission in that way. And then, of course, there's the full APIs for the much more robust engagement. And so this has been a significant focus over the last year in defining what the data management system really has to be. We've been talking for years about general capabilities and put numbers down for what that looks like, but the team has really put a lot of really crisp and significant effort into getting this idea of a science platform in place. And again, the documentation that exists in both slides and in data management reports is really quite good in describing what we have in mind at this point. So with that as our as the objective, you see in the next couple of slides some of the various aspects where the portal is very much Firefly based at the moment, and you can see here on this screenshot the kinds of things that is anticipated to be capable in that aspect of the platform, and some of the existing data sets and so forth, and analysis that's already been used in that context. And then on slide 25, we focus on the Jupyter Lab notebook, and then 26. Now 25 is there's no other image. You start to get a sense of what we're thinking about here. And again, I'm not going to do it as much justice as some of these other materials that we've made available in the past. But I think that the bottom line is that the crispness in where the DM design is headed is now well established, and I hope that you've all had the opportunity to engage in some of those details. And then so 26 is similar. You can read through that for the last part of what we're anticipating for being able to interact with the platform. So I put this last slide on DM, sort of thinking about what does this all look like for 2018, and another concept that's really been a focus for the planning for data management has been in what we've been calling the minimum viable system. And what we really want to do is get to the point where the system gets to that stage and then continues to increment in its capabilities going forward. And so that that we can really emphasize the fact that it's not like data management is not there until suddenly it is. In fact, it's very capable today. We are doing a lot of very interesting analyses with various portions of the data of the LSST stack. And one way to really emphasize that is to get to this minimum viable system. And so that's one of the things that we should be seeing later on in 2018 is to get hardware and some of the processes in place to really demonstrate that. Some of those details are in the next 5 bullets, where you can see some examples of things that are going to be replaced or be put in place as capabilities over the next year, including very soon some replacement of particular algorithms in January. At the end of the next cycle, you'll see some scaled versions of data alerts, and then you start to see some additional very hardware focused and system capability focused milestones later in the calendar year, including the network and then the calibration system. I mentioned that the calibration telescope would be up and running in 2018, and what we would like to do is be able to start commissioning that and actually pushing real data into the data management system as well, and doing some very early commissioning of more of the system using the spectrograph that will be in existence. So you get a sense here of what 2018 will look like for data management as well. And then I have a few more slides to show overall, if you think about the things that I just mentioned as really being very focused on the three major subsystems, data management, telescope and site, and camera, and all leading up to a certain level of capability, which we've always discussed as sort of being the higher level of organization for the project, and then leading into what we now call commissioning. And this slide really shows, we use this to show where the schedule contingency is, but also to show the phases of this work. And as we finish up those three major subsystems really focus on getting complete, it's the commissioning activity that really has to start ramping up. And that's shown on this particular slide as in purple. And Chuck has probably had opportunities to talk to several of you on his plans, and I'll touch on those a little bit here in the next few slides. But that activity is really starting now, and that's really another focus of this slide is to really emphasize that it's not just three subsystems coming together and then suddenly commissioning starts. But Chuck is already starting to work on building up his team and preparing the tools necessary to do the various parts of that commissioning activity. And then, of course, in the bottom right, you also see that we're also thinking a lot about how we transition and how full operation ramps up. And so, again, this is a bit of a cartoon, but it really gives us the opportunity to talk to these various phases and to really emphasize not just critical path from a schedule standpoint, not just when things are going to get done, but just what things are happening in parallel and how these other activities need to start ramping up. And so here's another, on slide 29, is another view of the commissioning activity and some of the sequencing. If you've heard us talk in the past, you've heard us describe commissioning as the first phase being integration and test, the second phase being science validation. But in fact, when we really start to focus on what does that really mean, you get into these, Chuck is now describing as 4 phases. The preparation phase, and then there's an early integration and test phase where we'll be using a single raft camera called CompCam, which will be used to really debug a lot of the system with this, which is much simpler but very capable camera. And then when the full camera arrives, then we'll get into full system integration and test. And then the science validation starts. And if I go to the next slide, slide 30, is another way to look at it, and it really allows me to emphasize that last phase is not just science validation and verification, but it's really just a whole series of mini surveys. And in fact, in this particular viewpoint, what you can see is, yeah, there's some installations and there's some various integration activities, but really the commissioning activity is to validate what's happening and to verify that what we're doing is meeting the requirements. And so in each case, Chuck has identified a series of tests that will be performed to really emphasize that the level of integration has been completed successfully. And then the last slide, 31, gives you a sense of what the current milestone dates are for these various levels of commissioning completion as we get into the end game. So again, I didn't want to use all the time, and so I went through a lot of that really quickly. But I think the bottom line is that I think the project is in a really good state. It is busy everywhere, in every corner across the globe, working on various elements of LSST. The construction activities that I've mentioned, the fabrication activities, both for the telescope and for the camera, even the machine integration going on for data management, all of the software development. They're all at various states of completion, and all coming together over the next couple of years. And so I think 2018, not just, 2017 saw the building sort of take form, but 2018, a lot of activity, a lot of hardware is going to be getting to that level of completion from the factory and getting into the next stage of delivery to the site. So I sort of have described it as a fairly transformative year for the project.
Brilliant. So should we open the floor for questions instead of going into the backup slides, unless there is anything? I've
I
seen the
wasn't
next
planning
few
on going over the backup slides. Those were really just there
Perfect.
for conversation
Backup.
if we got to it.
Excellent. So anybody has any questions? Now is the time. Why don't I start? Go ahead.
I have one. This is Neil Brandt. First of all, thank you. This is all great and very exciting. I did want to ask the status on of the call for mini surveys white papers. I recall on the SAC there was discussion that there would be a likely deadline for these of April 2018, but I haven't yet seen a call for proposals or even seen a proto call for proposals that would be discussed and revised by the SAC or by others. And so I just would like to know the status of that. Thanks.
Joko, are you on?
So for various reasons, we had to delay it a little bit. One of which is that we want to issue 2 calls together that originally we planned as 2. It will be one following SIC advice. So right now we hope to have it released, the call itself, in June, with the deadline for submitting white papers after summer, maybe October or November, something like that. We will definitely run the draft by SIC and various other reports, and we will start working on draft as soon as the overview paper is out, so roughly in January. So SIC should expect to see something in February, by the end of February at the latest.
Okay, thanks.
Let me ask you, Željko and Beth. I just want to point out that this timeline is quite critical for the science collaborations to organize meetings around these calls. So please keep us updated as this timeline may evolve, if it may evolve more, and as it approaches to being finalized. It's important for the science collaborations to know when the calls are going to be ahead of time enough to be able to organize a meeting.
Definitely.
Thank you.
That's a great point. And Joko, my understanding is that we're going to come, we being me, with input from you, come prepared to the AAS with a slide that summarizes the dates so the community knows what to expect. So A, Željko, is that correct? And then B, if it is correct, Federica's good point reminds me that whatever we show at AAS we should be sure to connect the science chairs with those slides.
I believe so, yes.
Okay, great. So that's the timing that you all can expect, beginning of January.
Brilliant, thank you.
Just a very quick
There
comment.
was
Sorry. The mini surveys that Neil's asking about, they are different from the mini surveys on Victor's slides. Is that right? The commissioning mini surveys are different from the mini surveys being called for.
That's correct.
So as a follow-up then, the mini surveys in commissioning, are they already defined? What's the process going to be for designing those mini surveys?
Still working some of that out, Phil, but the primary objective of these mini surveys, of course, is to verify and validate the performance as defined in the science requirements document and the other documents down there. What we have talked about in the past is calling for suggestions of, say, places on the sky, or perhaps some interesting cadences that would be done in an opportunistic kind of way without any guarantees being made. Because the first and foremost objective of commissioning is to deliver on the performance in the science requirements document. Is that so? We have talked about making a call for and providing a means for input to the commissioning effort. Myself, Steve, and Victor, and Beth, we haven't actually worked out the final details and when we would open that up. But so I would have to say stay tuned for now.
Thanks.
There's a question by Megan. Megan, do you want to ask it yourself?
Sure. So I just had a question about NCOA. Since being at Gemini, I keep hearing lots about it. How, if any, impact does, because LSST will fall in as well as Gemini, and NOAO will be one big happy family in some sense. So I was just wondering how, in terms of some of the operations, if there will be any impact from joining NCOA, which is supposed to be at the end of 2018, or if there is any impact, positive or negative, that might be happening. It may be not impacted at all, but I was just curious sort of how NCOA might fit into what's going on in 2018.
And actually, there is a question, a related question that I need to premise. What is NCOA? So whoever answers the question maybe wants to spell out the acronym.
Steve, do you want to take that, or shall I?
Start and then you go on, Beth. So just the first point, which I'll just make a brief point, and then Beth can talk more about the details. So first off, the construction project per se will never be part of NCOA. The construction project is its own or a center and will play out until completion and then disappear. And commissioning is part of construction. So most of what we've been talking about for the near term of how we go into commissioning is unaffected by NCOA to some degree by definition. What will go into NCOA is the operations of LSST as facility. Now, of course, that's 100% operations once we officially start the survey in October 2022. But there's a ramp up of the operations funding line, which will be under the auspices of NCOA, that Beth will lead, that will begin in 18 actually at a small level and continue up through 2021, 22 until it continues asymptotically into the full operation. So Beth, let me just leave it to you then to talk about how that fits.
Great. So the functionality that we plan for LSST operations is not at all affected by the implementation of NCOA. But I believe that our ability to recruit and retain a strong workforce through the entire 10-year LSST experiment is strengthened by the presence of NCOA, right? So LSST has been proposed as this fixed-length experiment, and because, Steve, we never defined NCOA.
Sorry, I didn't do that.
I figured, oh, Steve's going to define NCOA, but I'm going to finish my sentence, then I'm going to define NCOA, then I'm going to go forward, and it will make more sense. Actually, no, I'm going to stop my sentence because it won't make any sense if we haven't defined NCOA. So NCOA stands for the National Center for Optical and Infrared Astronomy. And it's a concept that's generally been in the air for quite some time, but that it's grown legs and moved forward over the last 2 years. And the concept is that with some analogy to the Space Telescope Science Institute, which is held up by several programmatic pillars, the Hubble Space Telescope, the James Webb Space Telescope, now WFIRST, a substantial EPO program. There's also, I forget the name of the division of it, Data Science Division led by Arfin Smith. There's this set of scientific missions and programs that the Institute is built around, and the staffing for those is fluid between them in this matrix management system. So, for example, you aren't hired just to work on HST forevermore, and then when HST's mission is ramping up, you're out of a job. You're able to move around and change your functionality over time, whether you're a technician, an engineer, or a scientist. And so the ground-based optical infrared system, which as federally funded in the United States, includes Gemini, includes NOAO, and will include LSST once construction is over. The idea is that these will form the three programmatic pillars of a national integrated center for optical and infrared astronomy, where ultimately, once this integrated restructuring is done, staff who are employed by any of these centers could, over time, switch their functional duties to go between any or the other, or any given snapshot in time. It may, in fact, support activities in more than one of the centers. Again, much like many staff at Space Telescope, at one point in time are supporting more than one of the different space missions, because there's a lot of activities in common to enable the science and to enable the technology. So there's been documentation submitted to the National Science Foundation formally a few months ago. We just had a review several weeks ago in DC that was run by the NSF to review the concept that was put forward in advance of this concept going before the National Science Board for making a recommendation to Franz Cordova and the NSF to whether to move forward with this integrated national center. And it looks like things are moving forward smoothly. If things go as expected, we will get to the formal green light to do this implemented integration of these centers, with a currently planned start date of the more integrated center of October 1st of 2018, although Steve said that very important point that LSST construction activities will not be part of this integrated center, but as operations ramps up, our staff will ramp up within NCOA. So you can imagine that with this larger set of opportunities, looking ahead to the future, you can imagine if there's, a future large aperture telescope that there's U.S. federal involvement in, the structure of NCOA is such that you can naturally fit such a new program within NCOA. If there's a new, wide field multi-object spectrograph on a 10-meter class telescope sometime in the next decade with federal involvement, this structure would naturally allow for such another new program to be implemented within NCOA. So folks who are employed by LSST through AURA, through NCOA, will be able to look ahead and say, there may be new opportunities for me in the future. I'm not going to be out of a job on the 364th day of the 10th year of LSST operations. And we also think just with a larger science, a technical, and engineering environment, it'll provide a quite stimulating environment to be a part of. So we're not changing our functional plans. I think it will enable synergies with Gemini and NOAO that will expand LSST science outside the boundaries of what we'll actually get funding for. In coordination with Gemini, potentially target of opportunity, work with their new single object spectrograph, NOAO's interest in supporting the community to do NOAO science and to help to build a time domain system. All of those ties will be strengthened. So it will be value added, but what's in our funding umbrella is not going to be different.
Excellent. Are there any other questions? So there's nothing left on the chat, and it's 4:59, so we're perfectly on time to wrap this call up. Thank you very much, Victor, for the slides. This looks terrific. I thought it was quite impressive and great to see that everything is moving at pace. As I mentioned earlier, I have a list of future PSD topics. I also have set up a Google Doc for you to propose more topics. We have a tentative calendar that I will submit to the chairs in the coming week, and we'll have the next meeting sometimes in January. Stay tuned for the date. I will upload the minutes and the summary of the meeting on community and open up a page for further discussion. And if there is nothing else, thank you very much for participating.
Thank you, Fed.
Thank you.
Thanks, Dad.
Bye-bye.
Bye, thank you.